Most of the universe is ruled by suns that don't shine. Massive, invisible, everywhere. If one crossed our system, we'd never see it coming. Tonight we start hunting the dark suns of space. Take a moment and picture the night sky. Not the washed-out version you see from a city, but a truly dark sky, far from any artificial light. You see thousands of pinpricks of light, each a distant, blazing star. You see the soft, milky glow of our own galaxy stretching across the heavens. It feels vast, complete. But this breathtaking vista, this entire cosmic census of everything we can see with our eyes and our telescopes, accounts for a shockingly small fraction of what's actually out there. The brilliant stars, the glowing nebulae, the galaxies themselves. They are all just luminous decorations hanging on an enormous, invisible architecture. An architecture of darkness. We're not talking about empty space. We're talking about objects with immense mass, objects that possess the gravitational might of stars, but produce no light of their own. They are the universe's great unseens. When we talk about these objects, it's easy to get confused. So let's be clear what we're talking about. These are not cold, rocky planets, adrift in the void. While fascinating, a rogue planet lacks the sheer gravitational authority to command a star system or sculpt a galaxy. And they are not merely dead stars, like white dwarfs or neutron stars. Those are the well-documented corpses of stellar evolution, faint but still detectable, the glowing embers of a fire that once burned bright. The objects we're hunting are different. They were born in darkness, and in darkness they remain. We call them, conceptually, the dark suns of space. This isn't a formal astronomical classification. Rather, it's a powerful idea, an umbrella term for a rogues gallery of cosmic suspects. These are massive, powerful objects with the gravity of stars and the influence of suns completely invisible to the human eye. They are the hidden puppeteers of the cosmos. On one end of the spectrum, you have the failed stars known as brown dwarfs. These are celestial bodies more massive than Jupiter, but not quite massive enough to ignite the fires of nuclear fusion in their cores. They smolder with faint residual heat, glowing only in the deepest infrared, forever denied the status of a true star. They are suns that almost were. At the other extreme, you have the most famous dark suns of all, black holes. These are the ultimate gravitational tyrants, objects so dense that not even light can escape their grasp. From stellar mass black holes left behind by colossal stars, to the supermassive behemoths that lurk in the hearts of galaxies, they are the very definition of a massive dark object. And then there's the most speculative, most mysterious candidate of all. The possibility that the enigmatic substance we call dark matter doesn't just exist as a diffuse halo around galaxies, but can also clump together into dense, massive objects all on its own. Hypothetical dark matter halos, or even primordial black holes forged in the Big Bang itself. These would be ghosts in the machine, shaping the cosmos without ever truly being part of the world we know. Tonight, we're diving into one of the darkest, most profound ideas in modern astronomy: the search for these dark suns. We will explore how these invisible giants are born, how we can hunt for them using warped light and wobbling stars, and how they may be the secret ingredient that allowed galaxies like our own to exist at all. These are the objects that shape galaxies, bend light, and control cosmic evolution, all while hiding in total darkness. When we look up at the night sky, we believe we're seeing the universe. We trace the familiar patterns of constellations, marvel at the faint, milky band of our own galaxy, and feel a sense of connection to the cosmos. It's a breathtaking, seemingly complete picture of reality. But this perception, as comforting as it is a profound illusion. The truth is far more unsettling and far more magnificent. Everything you see, every star that ever shone, every planet we've discovered, every nebula painting the void with gas and dust, even our own bodies, all of it belongs to a category scientists call baryonic matter. It's the stuff made of atoms, the tangible building blocks of our world. Yet, all of this, The entire visible universe makes up less than 5% of what actually exists. It's a mere cosmic footnote. The rest is invisible. A staggering 95% of the cosmos is hidden from us, composed of two enigmatic substances. About 27% is something called dark matter, an invisible gravitational scaffolding that holds galaxies together. The remaining 68% is an even more mysterious force known as dark energy, which is causing the very fabric of space to expand at an accelerating rate. Our universe is dominated by the dark. And the first clues to this astonishing reality didn't come from what we saw, but from what we couldn't explain. The story begins in the 1930s with a brilliant and famously cantankerous astronomer named Fritz Zwicky. While studying the Coma Cluster, a colossal swarm of over 1,000 galaxies, he noticed something deeply strange. The individual galaxies within the cluster were moving at tremendous speeds, far too fast to be held captive by the cluster's collective gravity. Based on the light from all the visible stars and gas, the cluster simply didn't have enough mass. It was like watching a merry-go-round spinning so fast that all the horses should have been flung off into the distance. Zwicky calculated that there must be hundreds of times more mass than what was visible, a substance he termed dunkle Materie, or dark matter. For decades, his revolutionary idea was largely dismissed as an eccentric theory. Then, in the 1970s, the puzzle resurfaced with undeniable force, thanks to the meticulous work of astronomer Vera Rubin. She wasn't looking at clusters, but at individual spiral galaxies. Basic physics predicted that stars farther from the galactic center should orbit more slowly, just as Neptune orbits the Sun more slowly than Mercury. But that's not what Rubin found. Instead, she discovered that stars on the outer edges of galaxies were moving just as fast as stars near the center. This flat rotation curve was a flagrant violation of the laws of gravity, unless there was more mass than we could see. Rubin's observations provided powerful, independent confirmation of Zwicky's earlier hypothesis. The galaxies weren't breaking the laws of physics. They were simply obeying the gravity of a colossal, invisible halo of dark matter in which they were embedded. This unseen substance was providing the extra gravitational glue needed to hold these rapidly spinning systems together, preventing them from flying apart. Something unseen was holding them together. Something massive. Something dark. This realization transformed our understanding of the cosmos. Dark matter isn't just a passive component. It is the primary architect of the universe. In the moments after the Big Bang, the universe was an almost perfectly smooth soup of matter and energy. It was the subtle gravitational pull of dark matter that began to draw material together, forming the first dense clumps. These clumps acted as gravitational wells, seeds from which all cosmic structures would grow. Normal matter, the stuff we're made of, was then pulled into these dark matter scaffolds. Like water flowing into a pre-existing network of riverbeds, gas and dust collected in the deepest parts of these gravitational wells, eventually collapsing to form the stars and galaxies we see today. Without dark matter, the universe would be a far more empty and desolate place, a thin, uniform fog of gas with no galaxies, no stars, and no planets. It is the invisible skeleton upon which the visible body of the cosmos is built. But what is this substance? We know it's there. We can map its influence. Yet we don't know what it's made of. It doesn't emit, reflect, or absorb light, making it utterly transparent to our telescopes. This has led scientists to a fascinating and tantalizing question. If dark matter forms these vast halos, could it also clump together on smaller scales? Could it form dense, compact objects that drift through the void? These invisible forces became known as dark matter, and within this cosmic shadow may exist what scientists quietly call dark suns. So, what exactly are these phantoms of the cosmos? What are these dark suns? The term itself is a conceptual umbrella, a way for us to categorize the universe's most elusive gravitational tyrants. These are not stars that glow, but objects that act like suns through gravity alone. They are the universe's hidden heavyweights, objects with enough mass to command their own patch of space, yet without the fiery heart of a true star. To understand them, we must first understand what they are not. They don't burn hydrogen, the fundamental fuel that powers the brilliant furnaces of stars like our own sun. They don't shine with their own light, remaining cloaked in perpetual twilight, yet their pull can dominate entire star systems, a silent, invisible force shaping the destinies of worlds. The most well-understood candidates for dark suns are objects called brown dwarfs, often called failed stars. These cosmic bodies occupy a fascinating middle ground. They are born from the same collapsing clouds of gas and dust that create stars, but they never quite make it. To ignite nuclear fusion and become a star, a celestial body needs to accumulate about 80 times the mass of Jupiter. Brown dwarfs fall short of this critical threshold. They typically range from 13 to 80 times Jupiter's mass. While they can't sustain hydrogen fusion, the immense pressure at their cores allows them to briefly fuse a heavier isotope of hydrogen called deuterium. This process generates a small amount of heat, causing them to glow faintly in the infrared spectrum, a dim, ruddy light invisible to the naked eye. But this is a fleeting phase. Once their deuterium is spent, they simply cool and fade over billions of years, becoming ever darker, wandering the galaxy as dim, massive ghosts. They are far more massive than any planet, but they are not true suns. They are the universe's stellar disappointments. This brings us to an important distinction. What separates a massive brown dwarf from a large planet? And what separates a small brown dwarf from a rogue planet, a world ejected from its home system to wander the void alone? The line is drawn by formation and mass. Rogue planets, even giant ones, are typically much less massive than brown dwarfs, often forming in a planetary system before being cast out. A brown dwarf, on the other hand, forms in isolation, like a star, collapsing under its own gravity. While a rogue planet is a lost world, a brown dwarf is a failed sun. Its gravitational influence is orders of magnitude greater, capable of disrupting planetary orbits from afar, not just colliding with them. But the category of dark suns extends beyond these failed stars into far more exotic territory. Some theories propose the existence of intermediate mass compact objects. These are not made of normal baryonic matter like atoms and protons. Instead, they could be dense clumps of the mysterious dark matter that we know makes up the vast majority of matter in the universe. Imagine a sphere, hundreds or thousands of times the mass of our sun, composed entirely of particles we cannot see or interact with. It would emit no light, no heat, no radiation of any kind. It would be utterly invisible. Its presence would only be betrayed by its immense gravity, a silent warping of space-time that bends the path of starlight and holds smaller objects in its thrall. And then there is the most extreme candidate, a primordial black hole. Not the stellar mass black holes left behind by collapsing giant stars, but ancient singularities forged in the fiery chaos of the Big Bang itself. These could be of any mass, from that of an asteroid to thousands of suns. A primordial black hole passing through our solar system would be the ultimate dark sun, a point of infinite density, a pure manifestation of gravity, undetectable until it was already upon us. These are the true dark suns of space, the failed, the unseen, and the unimaginable, all united by one defining trait: their silent, gravitational reign over the dark. Others could be even stranger, dense clouds of dark matter clumped together, forming invisible gravitational anchors. And then there are the most terrifying possibilities: primordial black holes, born moments after the Big Bang, roaming the galaxy like cosmic ghosts. Silent, invisible, deadly. What makes dark suns truly frightening isn't just their power. It's how difficult they are to detect. They don't emit light. They don't reflect it. The only way we know they exist is by watching what happens around them. Stars suddenly speed up. Light bends where nothing should be. Entire regions of space warp as if something enormous is hiding there. Astronomers call this gravitational lensing, light curving around an object we cannot see. A shadow with mass. Imagine traveling through space and feeling gravity pull at your ship, but seeing nothing ahead of you. No glow, no warning, just darkness bending reality itself. In some galaxies, scientists believe dark suns may outnumber visible stars. Entire stellar systems could be orbiting invisible centers. Suns that warm nothing, stars that light nothing, masters of gravity ruling from the shadows. And here's where it gets even more unsettling. Dark suns may have shaped our own existence. Without dark matter, galaxies wouldn't form, stars wouldn't gather. Planets, including Earth, might never have existed. The very reason we are here could be because of forces we cannot see, understand, or ever fully observe. The universe may be built not by light, but by darkness. So next time you look up at the stars, remember this: the brightest objects in the sky may not be the most powerful. The universe's true rulers don't shine. They don't glow. They don't announce themselves. They remain unseen. Dark suns of space, silently holding the cosmos together. And the scariest part? They could be anywhere, even closer than we think.